all. This is Mrs. Katowitz, another computer science lesson. And I have something fun for you guys to do. This should get you up and moving. So if you can have a phone or a tablet, you could potentially put this on and do this. Or you could do it from the computer. Either way. But we have done programming before, and so some of this should be, hopefully should be reviewed for all of you. Okay, now some of the vocabulary might be a little new, but as far as the programming, we did this back in around winter time when we did some programming. So first of all, the instructions. You will need a partner. Okay, one person will be the programmer and the other person will be the robot. The programmer will read the card, and you'll see the cards next. You're going to read the card to yourself, or and then you can either give the computer commands. The other person, remember, there's a computer here, okay, and you can either tell them the commands or you can write them the commands down. And then the computer will either read it or listen to the command and act it out just as they heard it. You can then debug a problem as needed. You can also switch roles so each programmer can experience being a robot and a programmer. Okay. So, important words to remember when you're programming. First, you have the program. A program is an algorithm that has been coded into something that can be run by a machine. Okay, just like a computer. A computer runs on programs. An algorithm is just like a step-by-step of directions. A recipe, for example, is an algorithm. Okay, and then you have commands within those algorithms. Okay, and they are instructions to the computer. The computer does not operate without instructions. Okay, and then looping, okay, is the action of doing something over and over again. Okay. The sequence is the exact order. Now, you remember in programming when we did this, that when we programmed something, it only did what we told it to do. If we had something out of sequence, then something didn't work, okay? So a programmer, okay, is a human coding a computer, okay? And then code is language that programmers create and use to tell a computer what to do. Now, oops, went too far first. Okay, debugging means when you fix the code. You figure out where you went wrong, go back through, trace your steps, and fix the code. Okay, computational thinking is basically think like a computer. Okay, the computer, when you're acting like the computer, if you are the computer, you follow the commands just like the programmer told you to do. Okay. Computers do not have a brain. They don't think independently. Therefore, the programmer must be very exact and give easy to understand directions. And then this is my favorite word, persistence. Okay. Programmers do not give up. Okay. When the computer doesn't do it, they go back and they debug and fix what's wrong with it. They don't just say, oh, this is hard, I give up, I'm done. We don't do that. Okay. Persistence means you have to have persistence. Try again. Figure out what went wrong. Fix it. Okay, so are you ready to get started? Now, first thing you're going to do is you're going to program your partner to move in a circle one time. And it can be either, okay, so in a circle, it's like 360 degrees. They're making a turn. So they're making a turn almost 4 times. So if you say, program your partner to move in a circle, you say turn left again, and they're moving. Okay, turn left again and turn left again. So they have moved in a circle. Okay, or you can say turn right again. So they're going to turn right, and then they're going to turn right again, and then they're going to turn right, and then they're going to turn right again. Okay, now program your partner to move in a circle 2 times. Now program your partner to move in a square. This is where they're going to step forward. Okay, so let me get my pen here. Okay, they're going to step forward, turn right, step forward, turn right, step forward, turn right, step forward. Okay, so that's going to be forward once, turn right, forward once, turn right, forward once. Oh, that sounds like a loop, a pattern. Okay, so you could say, repeat this pattern 4 times. Okay, okay, okay. You could say forward, okay, and then right. 4 times. Repeat 4 times. Okay. All right. Next, we have program your partner to move in square 2 times. Okay. So it could be, okay. So here's what I would do. Pull up my, we're going to go repeat 4 times. So we're going to use our repeat tool. This is okay, kind of our repeat tool. So we're going to repeat 4 times. Actually 8 times, because if we repeat this, if we repeat this 8 times, okay, all right, move forward, okay, and it turn right, okay. So now, got it? So now you're going to program your partner to move in a straight line. So you can just say, move forward. Now, a computer, you move forward. And you keep moving forward until the programmer says stop. Okay, so programmer, make sure you tell them they have to stop, because the robot will keep going until you tell them to give them a command to stop. Okay, program your partner to follow the algorithm below. These are steps, basically forward, forward, left, left. Okay, and those of you in my 1st and 2nd graders, and even my 6th graders, should remember some of this, okay, from when they were younger. But we used arrows, directional arrows, to command when we were doing programming. Okay, again, here's another one. Program your partner to follow, okay, up or forward, left, left. It's almost like a pattern. Program your partner to follow the algorithm below. Okay, forward, forward, right, right. Program your partner to follow this program. Program forward, right, right, right. Okay, so this one's kind of easy. Okay, just tell your partner to follow the arrow. So remember, backwards. Okay, so your partner has to step backwards. Okay, right, right, backwards. Okay, this is right, forward, forward, right. Oh, so I know that some of you have been studying cardinal directions and that you have done this. Sorry. Okay, so north, okay, is this way. All right. East is this way. South is behind me. Okay. West is this way, to your left. Okay. So again, if your partner says go north, 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 you're going to go forward, forward, forward. And then you're going to go east, east, east. Okay. So you're going to go right, right, right. Okay. And then you're going to go south. So you're going to take a step back. Okay. So same thing, south, 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 south. You're going to take 5 steps backwards. Then you're going to go west, west. Okay. Just think of that. So program your partner to go northeast, southwest, northeast, southwest. Oh, that sounds like we're going in a circle almost. Northeast, southwest. Okay. Almost like the compass rose. Program your partner to go east, 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 south, south, east, 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 south. Now, this is where you can create your own program. What kind of challenges can you come up with for your robot? Okay. Now, you have to use at least a total of 4 commands. Next, create your own program for your partner using 8 commands. Remember, I gave you a bunch of commands. You can use north, south, east, or west to make it a challenge, to make your robot think a little bit, or you can use just forward, forward, backward. Okay, forward, forward, backward, left, and right. Okay, so you choose which commands you want to use. Okay, now create your own program for your partner that is greater than or equal to 5 commands. That means 5 or more. So greater than is 5 or more. Okay. And next one, create your own program for your partner with a minimum of 7 commands. Oh, a word minimum. Minimum means they cannot be less than 7 commands. It has to be 7 or more. Okay. Now, once you have done all this, switch. Okay. Have your partners switch. So one person, the person who's a robot, they become the programmer. And the programmer becomes the robot. Okay. Now, a couple things to think about after you're done doing this. A couple things. If the computer could talk and ask questions, would it make the job of the program easier? What variable would make this activity easier or harder? What if you were blindfolded? Like you couldn't see where you were going. Robot, you would definitely have to make sure your programmer didn't get you into situations that were unsafe, right? And then what if you were deaf and you couldn't hear the commands? Okay, maybe you have to have somebody show you. Okay, how else could you solve the problem? What tools would you create to make this challenge easier or harder? Okay, so if you have any questions, you guys have my email. I'm going to email this out to you. Now, if you want to take pictures, parents, of your kids doing this activity, I would love, love, love to see the pictures of the kids doing this activity. It's a fun thing to do. And then I will email them to Kemper and explain to him, and he can put them on student shoutouts, because I would love to see you guys doing these. Okay, so again, a way to get out and make movements, but also understand how a computer and a programmer work together how a programmer codes a computer to make it work. All right. See you next week. Another fun activity. Bye-bye.